Welcome class to your at-home activities video for Lewis dot structures. I want you to remember the number 8, so keep this in mind. You should have already accessed our document here from your Google Classroom. So if you could click into it, it should be the very top one, the most up-to-date one. It's going to say Vesper and Lewis dot structures home activities guided notes. Okay, so I'll give you a second to do that. Hit pause if you need to, and then come on back. If you already came back, you'll notice that I want you to take this poll at the beginning. You're going to go to this Google form. Once you do, you're going to see that this will open up. You should see this banner at the beginning. You're going to be taking the short questionnaire about, have you heard of any of these compounds, these molecules right here? Some may sound familiar to you. If you did recognize some of them, give me some input to where have you heard of them from. And then you may have never thought about this, but what do they look like on the atomic level? Okay, we've been studying things about atoms. Now we're going to see what do these atoms actually look like in real life. So you're going to pick, like for H2O, which one of these would it be, and so forth. Carbon dioxide, and make sure to go all the way to the bottom. It's going to give you a score. This doesn't count against your grade. This is just to see if you have any intuition to being able to get these models. These would be our Vesper models. Okay, and we said I wanted you to think about the number 8. Okay, the number 8. And now let's go to the periodic table, and if we go all the way to the right side, I'm going to zoom in. Notice we have a bunch of 8s up here with the names of the groups. We're going to focus on the naming the bottom one. I think that one's a little bit more informative for our purposes. We've talked about electrons. I think I've mentioned valence electrons to the outermost ones. Well, this tells us that all of these guys, these are the cool kids. They have all 8 of their electrons on the outside filled. Everybody wants to be like them. These are very close because they have 7. They just need one more. These have 6, 5, 4, 3. Okay, this is going to help us because we're going to need to draw little dots around these elements to show how many they have, and this is going to help us to connect them together. Usually these guys, like for example boron, would exist all by itself, an atom of boron. Silicon the same, phosphorus the same. However, some of these, like for example carbon, nitrogen, oxygen, and some other ones over here, like to be in pairs. They like to be diatomic. Let's see what that means. Okay. So if you're following along on your guided notes, and again to remind you what that looks like, notice this one starts with the D. This is our missing one for right here. Most elements exist as single atoms, but some are diatomic, meaning they exist. There are 2 atoms that are of the same element that are bonded together. We're going to talk about 3 of them. There's some others that exist in this format, but we're just going to talk about 3 of them, okay? The first one we're going to talk about is our first element, which is way over here on the left side. We're going to talk about hydrogen, okay? It exists as a pair of hydrogen atoms connected together. So H2. The first thing we want to do when we're doing our Lewis dot structure, we'll put the element symbol for each one of our elements. Got this one, leave a space to the side. We're going to use dots to represent the valence electrons. Hydrogen only has 1 electron per atom, but for the larger elements, we're just going to consider the ones all the way on the outside. We don't care about the middle ones. So just put 1 right here. You could put it on this side, but just for the purpose of the next step, so these dots are our electrons, okay? So just to remind you, that's our electron. I'm going to use another color just to show you. Now we're going to play connect the dots. Notice he doesn't have a pair. He's single right now. He would like to have a partner with him, so he's going to join up with this one. He likes them. They're cute. Okay, they join up right there. They're going to be connected. Now, they're going to form a bond. and we're going to connect them this way. This is our first draft. This is our final draft. Okay. Hydrogen's happy because he only had room for 2. He has a 2-seat car. He doesn't care about most of the people wanting to get 8. Hydrogen and helium, they do their own thing. So this would be the Lewis dot structure for hydrogen would be like this. Okay, so make sure to write this down in your notes. There will be times in our home activities I'm going to have you draw your Lewis dot structures. You're going to upload pictures into the document. Okay, so make sure you're looking back at the document. So the first one that we talked about being diatomic was hydrogen. Now let's talk about another one, because you may think, well, are they all going to look like this? You just put the letter on one side, line in the middle. Now we're going to do our second diatomic molecule. We're going to talk about, there's others, we're going to talk about oxygen. O2, most of the oxygen that we are surrounded by, that we come into contact with, exists in this form. It's its most stable form. So again, we're going to go O and O. Let's go take a look at our periodic table. I have it over here zoomed in on the right side. Oxygen's right there. You can count from the right side. 8, 7, 6. It also says 6 right there for the 6 valence electrons that we need to put around oxygen. So we're going to put 6. Don't put 2 at a time. So we're going to do singles. And go in whatever rotation you want. Okay, so that's 4, 5, 6. Let's do this one. 1, 2, 3, 4, 5, 6. If you see any singles, we're going to connect them. These two, they're already a couple. They don't need anybody else. He would like to get with that one. She would like to go over here with this one. Okay, that's our first draft. It's all messy. The atom's getting all stabilized. All the attraction is happening. We're going to see what it looks like when it gets nice and stable. Let's put it over here. Okay. Put this one back. Okay. So as the final, we have our 2 oxygens. We're going to put these 2 bonds in the middle. So that's 4 electrons that are being shared between them. And then each of our oxygens still has its 4 valence electrons that are not bonded. Okay, so we're over here. This would be our final for our Lewis dot structure for O2. Okay. Now let's do the last of the 3 diatomic molecules that we're going to be doing. Let's do nitrogen. Okay, so notice this one had a double bond for erased hydrogen to remind you what you saw a couple minutes ago. This one had a single bond. Is nitrogen going to be the same as one of these 2? Or is it going to give us something different? If you remember, nitrogen I think was one of the ones I gave you on your pre-evaluation just to see what your hunch was about it. Okay, so our third one should be the third line on the diatomic molecules that we're talking about in your home activities. So N2, we split them up, refer to the periodic table, gives us a whole bunch of info about how things behave itself. Right there says 5, so let's go and do 5 around each one. So we're going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, I see some singles, some single folks on the side. These 2 get together. They get together, and it doesn't matter which ones you're connecting, get together. Notice the coloring reminds you, or it pops out more. So notice we're going to have 3 bonds in the middle. There's going to be a triple bond. A lot stronger than the double and the single, but it's also going to be shorter, by the way. We'll talk about that in the future, why that's the case. Okay, now we have to be careful. Notice there's one still peeking out right here. There's a pair on this one, and he also has one. And notice they're all nice and straight. Notice for the diatomic molecules that we've had, they form a straight line, so they're linear. So if we were to make a ball and stick model of them, it'd be like a little barbell like that. Okay. Notice that that one, just to point it out, they're together. The ball and stick model, the Vesper models that we're going to have, more 3D so we can see the bond in the middle. Those are just attractive forces, not a physical thing. Representations of what we're seeing in reality. Okay? So now let's get into, and I'm going to remind you, I'm going to pop back to your guided notes, because again, if you haven't gone into this thing, it has made it a copy for you. You should be able to type into it. Diatomic, hydrogen, oxygen, nitrogen. And then I'm going to see if you were paying attention and wrote the stuff. If not, hit rewind, slide it back. I want you to upload, and here are the instructions. You click insert on the top in Google Docs, pictures, and then from this device, pop it in there, okay? Same thing for the Vesper model, meaning with the ball and sticks, we'll go with that, okay? We're gonna put it right there. Okay, we're gonna do the same thing, number 2 for oxygen. Then we have nitrogen. And now we're gonna get it to a different one, carbon dioxide, one of the other ones that was on that pre-evaluation, CO2. But now there's going to be more than one element, so we're gonna have to count and keep track of stuff from the periodic table, okay? So I'm gonna pause here so that depending on your home internet access, to make the video shorter, okay? So I'll have another video short.